Thank you guys. Hope you can hear very well, especially on the back. Welcome here to PyCon 9. I will talk with Daniele Esposti. We're talking about evolution or stagnation of programming languages. A little introduction of myself. I'm data platform lead at Badu and daily working with Python, JavaScript, and Java. 30% each, so I switch in different languages. I'm not stuck on a single language. And today I'm not talking about history of programming languages because I think Wikipedia is much more interesting on this side and much more has much more information from me inside of me. So today I think I will talk about modern programming languages. So I will talk about the future, not about the past. What's a language first? Because you're talking about programming language. So in the word the programming language, there is language. But what's the definition of a language? We can have a look at the Oxford Dictionary, it's the definition of a language, and say that is a method of communication, either spoken or written, consisting of the use of words in a structured and conventional way. So programming language is a language. Right? Yes, actually yes, because it's spoken. You can speak the programming language. You can say, okay, you can write it. And as any language, it evolves by the people who spoke the language, because actually the people who need to communicate need to explain things within each other. So they need to adapt the language to the new requirements of the environment. So they need to change the language to adapt the language to the new variable inside the environment. And what's happening when these requirements, the language is not able to adapt to the new requirements of the people which use it? Well, you can sign it, because you can evolve the language, you cannot change it. You cannot add new words, or you need to use words coming from a different language, and at one point the language is not useful anymore. And people start to use that language less and less because it's less useful, it's less meaningful. The transmission and communication using that language is less. So at one point, well, people stop using it at one point. And this is applying also to programming languages, because as I said, programming language is still a language. Obviously, it's not a language used to communicate between humans. Well, yes, you communicate between humans, but actually it's a language to communicate between humans and machines. And that means the rule for a language apply also to programming languages. And we have a couple of examples about this was happening also on programming languages. So when programming languages start to have this kind of issue. And I will consider two very popular programming languages. Python, obviously, we have a Python conference, and JavaScript. I will start with Python 3, which I think all of you know about what's happening in Python 3, the upgrade to the language, and all the issues that came out from the direction. Let's see first what Python 3 means. So what kind of new feature give us? The print as a function, which is, well, a very small change, but actually one of the important change. All string and Unicode, which I think it was one of the most important changes for me. Some renaming of standard libs, standard library, which was useful to clean up the standard library, but create some issue on the code base, because now some packages, some modules are in a different, has a different name or a different package. So that's why 6 come out with the 6 moves, which allow you to use to be compatible between 2 and 3. async await. I never played yet. Didn't play yet with async await. I think it's super nice and super useful for asynchronous programming and congruent programming as well. F strings in Python 3.6, I think, if I remember correctly. Subgenerator, yield from, and yield. Fantastic. But that's all. So in Python 3, we adjusted 6-7 improvements. Very few additions from the Python 2.6 series. But the core language is still the same, so there's not so much change actually on the language itself. You can still recognize very well a Python 3 and Python 2 code base because there's not so many differences. Also, all the changes in Python 3 are not backward compatible in general. So if you write code in Python 3, you can really run in Python 2, or it's not easy to port in Python 2. Some of them actually are compatible, backward compatible. You can activate them with the from feature import and name of the feature, like print as a function or Unicode literals, for example. But not all of them. Also, you need to modify your Python 2 code to be able to use a new feature. So, yeah, anyway, there was anyway a lot of improvements from the point of view of the Python interpreter. I mean, the point of view of performance, new packages to like the async await, and low memory usage as well, especially in the dictionaries. So it's not that wasn't a nice upgrade. There was a lot of interesting stuff, but was more concentrated on the language itself. Actually, there were not so many changes. The changes were more on the underlying engine. And I want to do a comparison with what's happening in the same timescale on JavaScript, so ES5 and ES6, the latest two versions of the language. They have set and getters, new methods for the object and array objects, constant let, block scope variables and function. Arrow function, the lexilot this, which was very important to fix what this pointing to. Default parameters in functions, which we have in Python, but they didn't have in Italia, and now they have it as well. Spread rest operator. Template literals, which are kind of S strings as well. Property shorthand, a way to. Is it difficult to explain words? Maybe I can show you some example later. Computer property names. Method properties in objects. They did a lot of work on the structuring, so array matching, object matching. You can also extract information from objects in a hierarchical way, so you can go deeper into the object. They had the import and export, which was a very, very important change as well. Classes, which some people, they say that actually classes in JavaScript is not very useful, but I think there are some nice use cases. Iterator and generators, which you know how much they are nice and useful, especially in Python. Map and set and weak map and weak set. Typed and shared array, promises, and async await, which are kind of synonymous, but they are completely different usage. But they're kind of the same as async await in Python. Practicing reflection and collation, which is a better way to handle some internalization information in the browser. That's for just changing the language itself, not change on standard library, change on the underlying engine, because in JavaScript you have completely different engines, V8, Gecko, whatever. They're just changing the language. And there were a lot, actually. Just so we have probably 4 slides for that, comparison to 2 slides from Python. But a very important thing is no backward incompatible changes. So your code in ES5 is still working in ES6 and 7 and whatever. And this new code can be run in any browser. So you don't need to force a user to upgrade the browser, where in Python you need to upgrade the your interpreter to work on a new version of Python. You can already write Python 3 and run in Python 3 and Python 2, or write in Python 3.6 and run with a new feature in Python 3.6 and run it in Python 3.5, for example, because f-strings are not there. So I will come back later about this, but keep in mind this thing, which is very important. So in the same time scale, which around 10 years actually, one language improved just a little. I don't say that it didn't do any kind of improvement at all. It was just a small improvement and not a very big jump, because I think, for example, the Unicode strings was one of the most important changes, and also the performance itself. But from the point of view of the language itself, so what we are writing, what you are communicating, on the same scale, there was not so much. So it's still like writing Python like in 10, 15, 20 years ago. There's not really so much change compared to JavaScript, which are actually completely different now. If you look at some code writing ES5, ES6, it's completely different from the ES5. It looks like not completely different language, but it looks like a different language. So it just evolved. What's happening? Why a language which has a much more restrictions was able to evolve much faster than Python, which has less restriction, because we don't have restriction on the browser. So we can upgrade the line interpreter whenever we want. We can have control interpreter, where JavaScript doesn't have a control interpreter, because well, you can force the user to upgrade the browser. Guido, you know all about Guido, come up with a retrospective about Python 3, which is very, very clear what's happening. They didn't do any kind of runtime compatibility. So, as I said, new feature in Python 3 are not backward compatible. So you can really take Python 2 code and use Python 3 features. They didn't do any nice fully automated conversion tools. So if you want to, if you have a very small code base, it's very easy to maybe upgrade a new version of Python. But if you have a big code base and you are a pressure of the business to deliver, try to upgrade your entire code base is not very easy. And you can even upgrade piece by piece, because they are compatible. So, or you make it compatible on both 2 and 3, but it's still the same to do all the job. They didn't give any compatibility allowance, so they, like in Python from 2 to 3.0, if you have in Python 2, for example, you have a string with Unicode, the U modifier, U prefix, that was not supporting Python 3, so that breaks your code, so there's no compatibility, so you need to change it, you are forced to change it. And in some cases, they decided to do some changes without thinking about the consequences. So, for example, in the standard lib, they just do a big cleanup, change everything, and or you upgrade all your code to use the new name and packages for the standard library, or you need to use 6 moves. That was a little messy, because, well, I need to remember now, okay, this class now is like that package is now the name is completely different. It's a little confusing. In JavaScript, however, the committee, the TC39 committee, was really, really careful to not do anything. So, because you have this constraint about the browser, about the environment where the language is run, they didn't want to change anything, because otherwise it's broken. Otherwise, new code doesn't work in old browser. So that was one of the important part. ES5 code is still running in ES6 and ES7. So the old code you have, the old code base, is still compatible with the new version of the language, which is beautiful, because now I can start to work on using the new language, and I don't need to convert all my old code. I can convert my old code piece by piece. It's still working. It's still compatible. If some features are not available, you can use polyfills, so you can have some kind of backporting of the new feature. And so in this case, is that why you can run the, for for example, you can have new features in an old version of the browser because you have a runtime which provide them, if the browser doesn't provide them. And to use a new language, a new functional language on an old browser, you can transpile it with Babel, which is kind of tool like a 2 to 3, or well, actually 3 to 2, which allow you to actually convert your code to a new version, to an old version, transparently, and integrate it inside your pipeline. So you don't need to think to write your code and run a tool. And it's completely integrated, and you can expand it because it's made by plugins. So every time there is a new feature of the language, you can just add a new plugin for the new feature. So you don't need to upgrade it to itself. To itself is just an engine which runs plugin to transpile the code. And that allows you to actually take the new ES6 and ES7 running in a browser which can be, I don't know, Explorer 10, 11, whatever. So, as a recap, old code is still working. Think about 2 million lines of code, still working. New code works in old browser with the transpiling, so I can say, okay, now I want to use a haro function. Yeah, but my users, they use a very old browser. Who cares? Because it will transpile. So I can mix the old code and new code because they're compatible. As I said before, the old code is still running. In Python 2, code is not running anymore in Python 3, so you need to upgrade it. And also, I don't need just to stick to the latest stable version of the language. I can also maybe use a cutting-edge feature which are not released yet, which is called yes next. Still get transpiling because I can transpile absolutely new feature still in prototyping version, say, which is stage 1 or 2, and run it on old browser because I can use the transpiler. So, lesson learned, because I think for every problem, for every situation, you need to learn something about that. I think developers are more productive when upgrading their programming language is painless and seamless. So, which means I don't need to stop rewriting the entire code base in a new version of the language. Should be transparent, should be just adding, just an appending, just not an update on the language, an append, an addition to the language. In this case, you don't need to convert all part of the code. And this increases also productivity because I can work in a new language without having a time where I need to stop and rewrite. And it's painless. Also, well, also much more cheaper because you don't need to spend resources and money and time to convert your old code. The tooling is very important. G23 was a kind of interesting tool, but actually didn't break through. It wasn't part of. No one came out with a kind of pipeline, or the tool wasn't able to convert actually very well your code. For example, if you run G23 twice the same file, so you convert the file from Python 2 to 3 and run again 2 to 3 on the same file, actually try to convert again the same code, which is already Python 3, so it's not really able to understand which version of Python you have on the code. So it wasn't really a very useful tool, but Babel actually succeeded in this case because they build an engine to convert code, and they build plugins to convert the code. So now it's much more expandable. Anyone can extend the tool and become from the start become part of the pipeline. So you already have a pipeline in JavaScript for different reason, but this tool was become part of the pipeline. So it's completely transparent from the point of view of the programmer. All the new language coexist. That's, I think, is one of the important part. Just a little digression, for example, Kotlin. Kotlin can import Java code, so you don't. Two versions of the different languages they exist as well, and that is one of the best selling points. And JavaScript as well. Old version JavaScript is still working on the new version of JavaScript. And I think it's very important, this thing. I don't know the scale of the project you're working on, but when you're working with a code which is more than 100,000 line, well, that's mandatory. Also, I think we need to explore how other languages, other ecosystems approach the same issue, the same problem, how they solve it, because sometimes you try to reinvent the wheel, but sometimes it's better to stop looking around and go outside your kind of comfort zone, outside your language, outside your normal technology, and look at how different technology they solve the same issues, because maybe someone else has the same issue, the same problem, and find a solution which maybe is not perfect for you, but maybe there are some good ideas which can be reused. So, for example, here I can see the idea of Babel, the idea of a transpiler, which can be maybe ported in some way on Python as well, and having some way to have the same kind of pipeline on Python, which would be fantastic from a point of view, because in this case, your code base is not tied anymore to the interpreter. You can have you can write Python 3.6 code and run Python 3.2, for example, because you are running for some reason just 3.2. You're not bound anymore. And so that is one kind of idea which you can port from different technology or language. And I think the language should be ergonomic, should be written around developers, not force developers to adapt to the language. And should evolve fast, because, well, the technology is evolving fast and the requirements are they're changing. Some very nice feature in a different language not present in other language, like in Python. I don't know, for example, pattern matching I think it's fantastic, but we don't have in Python. But not having some feature slow down the way we write programs, because we need to write more code. Maybe having some kind of shortcut in the language can be useful to make the code cleaner, much more understandable and maintainable. So it should evolve faster to match the needs and the developers and the business and the environment, and should match the developers' needs. So developers should be the final users of the language, not the consumer. I think Python is one of the most successful language. I use Python since 2003, actually, for everything. It was fantastic, very clean, fast from what the kind of job I'm doing. But I think lately is kind of restricted. There's not. I found much more useful languages which are evolving fast, because I can really write less in a much more cleaner way. So I think it's a little. There's some kind of stagnation on the Python language, because I can see other languages are moving faster, and they don't have any kind of the problem on implementing new feature. But in Python, we just found out that we take 10 years to move from Python 2 to Python 3. At one point, they decided in the 1st of January next year to stop completely supporting Python 2.7. But after 10 years, it's a long time. You can see a problem here, actually. So I don't want to see Python stay like this for so long. I want to see Python evolving much faster, evolving in a better way. I want to see some nice feature in Python, a better feature. I want to see it thrive, not be a language like Greek or Latin, which at one point may be completely replaced by something else. So, thank you. I hope that my little talk was interesting and you opened your minds as well. I really wanted to show this kind of differences, because when you work on two different languages and you see the difference on the community and on the language itself, is very, very important to, from my point of view, to try to take the good parts and and try to push the good parts in the different language. And I think Python needs a lot of need to push much more in this direction, actually. So thank you, and Thanks.
We have plenty of time for questions, so go.
Yeah, hello. I have a couple of things to say. The first one, you didn't mention new typing feature in Python, and also that meta programming in Python was improved quite a lot. And my question is that JavaScript back then wasn't a good language to do programs, and it do a huge progress. Do you think that at some point in the future it will be comparable or will be able to beat Python?
Can you repeat the first one? Can you repeat the first question? Because it's two questions, right?
Oh, it wasn't a question. I just said that there's also a typing, a new cool feature in Python 3. Well, it's like 2 or 3 years old, and and huge improvements to metaprogramming.
Well, metaprogramming in JavaScript kind of exists, but it's not really powerful like in Python, because actually there are two different languages and two different scopes. So that's is a difference. And I didn't talk about the notation because actually, we have there is a notation in Python, but actually at the moment it's not really used by the language itself. Actually, because the interpreter can support the notation, but actually just set up the notation and it's not used. So that actually, from my point of view, is a kind of mistake, because I think a notation is useful to instruct the interpreter to say, this is this type, don't check the other types, be faster. For example, this variable is always an integer, so you can optimize the interpreter on the execution for that to be an integer. So I think that was a kind of missed opportunity for the Python itself. And I really want to see, for example, in Python 4 to use this annotation to be much more part of the language, in the sense of it's not just like a documentation, but much more a part of the execution of the language, a part of the inscription of the language. And metaprogramming, I didn't talk about that because actually I want to compare kind of apple to apple, actually. So that is much more like classes and classes, which is a Python and JavaScript. My metaprogramming is actually different between the two languages, so I didn't compare that one.
Hi, hello. Can you go back a few slides?
2 slides.
Again, here.
Yeah.
Now, When you say it should be ergonomic and evolve fast, is this your opinion, or you get this out of some data? Because actually, what I'm seeing here is an opinion. You said it should be fast, but I say it shouldn't. For example, actually, not really. I take the example of Golang, which is going very slow, and I love it for that because they are doing things very carefully, and they are carefully considering the effects of every new feature added to the language. When you don't do that, or even if you get it slow and do that, you may get things screwed. Language get very complex. For example, in C++, it's a mess right now, okay? And now they are trying to go fast, but being retrocompatible, the language, it's huge. It's a mess. It's hard to create a parser for the language. It's a mess. So why do you say this? I mean, there are so many examples and counterexamples that I'm wondering, is this an opinion, or is this obtained from data? Do you have statistics that say it should be better to evolve fast or not?
Well, first of all, I think it's an opinion. Because, well, for my usage, personal and daily usage. Second, there is data, because actually JavaScript is an example. The C49 is doing the same. So they don't want to break. As I said, they are forced to not break the compatibility. So, and it's still fast. Well, kind of fast, actually. you can really fast, like every year just come out with new version language. But they found out I think they found out the correct balance between retrocompatibility or forward compatibility, depends on when the point of view you're looking for, and the speed of adding new feature. So I think they can find out the correct balance in this situation. So is that why going slow on adding feature doesn't mean that you are adding feature without break anything, because actually in Python they broke something, having going slow. So I think it's not the speed of releasing new feature, but it's the mindset when you design the feature. So the mindset when you are approaching the problem. So if the mindset is, I don't want to break anything, but I want to deliver this feature, and then I want to try to find a solution for that, I think that's the correct mindset, actually. So yeah, coming back on your answer, yeah, first of all, is my opinion, kind of, and second, because, well, it's backed by the example of JavaScript where they make an ergonomic language for developers in a reasonable amount of time.
Questions? Okay.
My question is that why Python community have decided to support Python 2 this long for 10 years or more?
As far as I remember, the first issue was caused by the compatibility with packages like NumPy, SciPy, Pandas. Pandas I don't think so, but NumPy, SciPy, other packages which were compiled in C. The ABI on Python 3 was different, so they need time to convert to be compatible with new version of the interpreter. In the meanwhile, people that were not able to use these packages, so they were delaying the upgrade the new version in language, plus also Guido said in that retrospective, because that was just one part of the slide, but I just shared the slide later and suggest you to go to watch this video. He said that actually another problem was caused by the dependencies, because if your project depends by 10 packages and only 9 packages they are compatible with Python 3, you need to wait for the 10th package to be compatible with Python 3 before moving to Python 3. So you need to wait for all your dependencies to be compatible with Python 3, and after that you can start to upgrade with your language. So that creates a long wave, a long delay on upgrading new version of the language. Where, as I said before, if you're able to run the old version, to have an old version, new version language coexist on the same level, on the same interpreter, you don't need to wait for all your dependencies to upgrade. You can upgrade now. So that was my main reason why, actually, one of the main reasons why actually there was this kind of delay on moving to Python 3, because well, you need to wait for all the dependencies. All the packages using C, using the API on the Python interpreter to be converted, and after that you can start on moving in the Python 3, and that can take 1-2 years. Depends also on your business. Business doesn't allow you, not allow in the sense that it doesn't force you, but you don't have time and resources to migrate. But actually you get stuck in the version. So as an example, we organize next quarter, we organize a sprint to convert all our code on Python 3, but it will take maybe 1 month, 2 months, because there are a lot of very critical parts which are written in Python, and now we need to port in Python 3, and we need to test them, and we need to test them kind of on production, because it's very difficult to test in a controlled environment. So that's a cost for the company. So if the company before didn't have any kind of enforcement to move on Python 3, say, well, let's say Python 2 is too expensive to move. So there are different reasons. So packages, dependencies, time for you to upgrade the language, and also the cost for the company as well.
community of the Python is responsible for this issue to upgrading the core packages of Python, or who is responsible for this upgrading fast? Because 10 years is a long time. It can be done in 5 years or less, I think.
Yeah, the community is also responsible. I think yes. The thing is, community and single developers, because the community can in this case can provide maybe some tools to allow you to help you to migrate a new language. But also, as I said, if the community helps you learn a new language, but there are some packages, some parts which are not, some packages which are maintained by some maintainers, and that part is not updated in new language, you're still stuck. So there are different, variables which delay the upgrade in new language. Is that why probably having something which is much more, which is seamless, which allow you to have old version, new version of the language together, is allowing you to go on the new version without, in a very painless way. So in this case, I think the community probably didn't think about this problem. Probably, I don't know if Python, I don't remember if Python had this problem before to have a kind of breaking change between versions, maybe from 1.1 to 2, but probably Python 1 wasn't used so much, so maybe from 1 to 2 was much more seamless process than now from 2 to 3. So I think this is a nice occasion to learn some lessons and try to, in the new version, maybe Python 4, not do the same mistake again.
So before the last question, I'd like to remind you that you can leave a feedback dropping a star inside the PyCon 9 app. Okay.
Don't you think that if we keep backward compatibility, we cannot do real optimization when we change and upgrade the language? Not our optimizations as developer, but the developers of the language.
That's a risk. That's actually a risk. But you can actually mitigate the risk because, well, as I said, in JavaScript, they cannot break the language because you don't know when the oldest browser will be not used anymore by any user. So in this case, they have a very strict constraint. In our case, we are we have much more freedom because we can choose interpreters. So you can decide maybe, okay, because Python 2.7 is not supported anymore. Maybe when Python 4 will come out, you can say, okay, now all the features in Python 2 are not supported anymore, and you can do a kind of deprecation of the feature. You know what I mean? And you can do it maybe in a cycle of 10 years, 15 years, whatever. In this case, you can remove all code when the older version of the Python interpreter is not there anymore. So I think you can relax a little and you can simplify a little, and you can go forward in removing old features. Obviously, the life cycle will be a little longer, but you can do it. But yeah, the only difference is in your case, in Python is you can do it when JavaScript they cannot do it because in JavaScript the first version of the language will be there forever, but not in our case.
That's all, folks, and thanks, Daniele.